In the name of Allah, the most merciful and the most compassionate, and Prophet Muhammad, peace be upon him. Audiovisual medicine tutorials and manners. My tutorial today is audiological evaluation in pediatrics. This tutorial is longer than the previous tutorials as it is in 1 unit, so keep watching. Let's move on. Audiological evaluation in pediatrics has two main groups, behavioral and objective. The objective one, ABR and audioacoustic emission, the behavior observation audiometry, visual reinforcement audiometry, play audiometry, and conventional pure tone audiometry. The behavior observation audiometry, the child is seated between two loudspeakers and the audiologist delivers signal and notice the behavioral response of the child to sound. It is done up to 6 months of age. The visual reinforcement audiometry done with 6 months of age up to 3 years. The child is seated between two loudspeakers and the audiologist delivers sound and notice the behavior response of the child and with the distractor toy. The play audiometry is very common in our clinics. The advanced audiological evaluation, ABR, which is auditory brainstem response, and audioacoustic emission. First of all, what is an ABR? The auditory brainstem response is the representation of electrical activity generated by the eighth cranial nerve and the brainstem, a response to acoustic stimulation. The generators of ABR, we have 7 waves. The most common waves are the first 5 waves, and the most common one is wave 5, which is the most important one. Wave 1 from the distal part of the eighth cranial nerve, wave 2 from the proximal part of the eighth nerve, wave 3 from the cochlear nuclei, wave 4 from the superior olive, and wave 5 from the lateral lemniscus or inferior collicles. This is the ABR waves. The 5 waves occur within 5 to 6 milliseconds after the onset of the stimulus. These generators of ABR. The adult form of ABR within 24 months of age. The infant ABR is less waveform morphology and increased absolute and inner wave latencies. ABR used for threshold detection, for site of lesion localization. It is a part of electrophysiological test battery for diagnosis of central auditory processing disorder. It is used in otoneurological diagnosis like CB angle tumor. It is used in hearing aid selection, hearing aid fitting, hearing aid evaluation using aided versus unaided ABR. It plays a role in cochlear implantation and electric ABR. It is used also in intraoperative monitoring of CB angle tumor surgery, and it is used in newborn hearing screening, which will be discussed in another tutorial, inshallah. ABR trace. This is normal ABR trace. We can see here it is identifiable and repeatable ABR waves could be traced down to 30 decibel and HL reflecting normal hearing sensitivity in the frequency range 2 to 4 kHz when we are using click ABR. This is absent ABR waves, is not ABR waves when in the maximal stimulation at 90 decibel and HL, reflecting severe to profound hearing loss in the frequency range 2 to 4 kHz. In that case, we have to do 2 things. The first one is to do a 2 impulse APR 500 Hz to evaluate the low frequency region of the cochlea. And the other thing to do a otoacoustic emission. It may be a case of auditory neuropathy spectrum disorder or auditory dysynchrony. This is threshold estimation. This is an ABR trace. We can find here The ABR waves identifiable and repeatable ABR waves could be traced down to 60 decibel MHL, reflecting moderate hearing loss in the frequency range 2 to 4 kHz when we are using a click ABR. We said it is a moderate and not a moderate to severe hearing loss, as we do a correction factor 50 decibel MHL. Let's move on. Bone conduction ABR. A bone conduction ABR is a modification of an ear conduction ABR testing. It is used in abnormalities in its external ear or the middle ear, metatarsia, microtia, and it is used to evaluate the sensorineural element to bypass the outer ear and the middle ear and stimulate directly the inner ear. Bone ABR recording through transducer is used. A bone vibrator P71 with a headband and headphone using a supra or a headphone or interphone. This is the electrode placement and the transducer used. I prefer to use handheld method for the bone vibrator for less artifacts and remove the headband. And the other thing, I prefer using the interphone for the same issue. The interphone less artifacts than the conventional super or earphone TDS39. The stimulus is click or tone pulse, and its contralateral masking is completely important, and the inner ear attenuation is 0 for the bone vibrator. What about the bone conduction ABR problems? It has no calibration standard, and as we said, the crossover or the inner ear attenuation is 0, which is essential to do a contralateral masking. The limited output for the bone vibrator, the maximum output is 60 decibel NHL. This is a bone ABR trait is that the latency is delayed. It is normal delay than the air conduction ABR within 0.5 millisecond. And other issue, the frequency range of the bone conduction ABR is different than the frequency range of the air conduction ABR, as the bone conduction ABR frequency range around 1.5 kHz. Let's move on audioacoustic emission. This is a model to how the audioacoustic emission device works. The sound delivered to the ear canal through the middle ear into the cochlea and return from the cochlea to the middle ear to be detected in the outer ear with the highly sensitive microphone in the top of the audioacoustic emission device. We have two main groups of the audioacoustic emission: spontaneous, which has no clinical significance, and evoked. The evoked audioacoustic emission are two main parts: the transient audioacoustic emission using the click stimulation, and the distortion product audioacousc emission using two pure tones. The transient audioacoustic emission present when the hearing threshold below 35 decibel. It is fast and used in newborn hearing screening. The distortion product audioacoustic emission use two pure tones. It is present when the hearing threshold below 50 decibel. The audioacoustic emission generally is highly sensitive to middle ear pathology. Any middle ear pathology can affect the audioacoustic emission, like sacroiliitis media or tympanic membrane perforation. As we can see here, transient audioacoustic emission pass, the signal to noise ratio is more than 3 decibel. You can see here. This is not passing audioacoustic emission transient, as the signal to noise ratio is less than 3 decibel. Thank you for watching, and see you later, inshallah, in the next video concerning neonatal hearing screening. Assalamu.